This is a video in sections 13.1 and 13.5, the distance formula and midpoint formula. In chapter 13, where we are working on coordinate geometry, which is the geometry of things in the coordinate plane, the x and y axes. So let's focus on 2 points in the coordinate plane. We want to be able to find the distance between them, and we wanted to be able to find the midpoint of the segment that connects them. So first, the distance. How do we find the distance between 2 points in the coordinate plane? Well, if they are both on the same horizontal line, then to find their distance just means you can count from one to the other, or you can subtract their x-coordinates. 3 minus -1 gives you a positive 4, and that's the distance from A to B, because they're on the same horizontal line. So the y-coordinates don't matter, just work with the x-coordinates. C and D are on the same vertical line, so their x-coordinates are the same, so we'll just subtract their y-coordinates. 1 minus -2, and that'll be 3. Now you may ask, what if we did -2 minus 1 instead? Well, that's -3, but a distance is always positive, so if you get a negative number, take its absolute value and treat its distance as a positive 3. So in that case, it doesn't really matter the order in which you subtract them, as long as you take the absolute value of your answer. But what if they're not on a horizontal line or on a vertical line? Like A and B in this picture on the right here, they're not horizontally next to each other or vertically on top of each other. So how do we find their distance? Well, their distance is the length of the segment that connects A to B. We can make that the hypotenuse of a right triangle if we just count down from B and over from A until we meet at the same point. Then we have a right triangle, and we know 2 of the sides. We can count how far we go on A. We go 3. We can count how far we go down from B. We go 4. And so what can we use on a right triangle to find the length of the hypotenuse when we know both of the legs? It's not a 30, 60, 90 triangle. It's not a 45, 45, 90 triangle, but it is a right triangle. And so the Pythagorean theorem works. 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 9 plus 16 is 25. 25 equals c squared, so c is 5. So that distance from A to B is 5. Turns out we can always use the Pythagorean theorem then to find the distance between 2 points. So that leads to the distance formula. The distance d between points x1, y1 and x2, y2 is given by the square root. Notice the square root was the last step we did in solving for the distance up here. So the square root of x squared the square root of x2 minus x1 squared plus y2 minus y1 squared. So subtract the x-coordinates, square that. That's what 3 represents up here, subtracting the x-coordinates. We squared it and we got 9. Subtract the y-coordinates and square that. That's what 4 is. We squared 4 and got 16. And we added them together and we took the square root. So the distance formula is really just applying the Pythagorean theorem, but it does so directly in the form of a formula. So let's use that. Find the distance between points -4, 2 and 2, -1. According to the distance formula, that distance is the square root of x2 minus x1. It's just natural to call the second one they gave us x2, y2, and the first one they gave us x1, y1. But really it won't matter as long as we're consistent. So we'll do 2 minus -4. Be careful with your negatives. Make sure you're subtracting each number. Squared plus y2, which is -1, minus y1, which is 2 squared. So that distance is the square root of 2 minus -4 is 2 plus 4, and that's 6. So we've got 6 squared. Plus -1 minus 2 is -3, so we've got -3 squared. We'll square both of those. Get 36 plus 9. Because remember, when we square a negative number, it becomes positive. Well, what's 36 plus 9? 45. We don't know the square root of 45, but we can simplify it because 45 is 9 times 5. So that gives us 3 radical 5 as that distance. If you recall, a circle is all the points that are a fixed distance away from a given point. So we can extend the distance formula to come up with the equation of a circle because it's all the points that have the same distance from a particular point, and we call that distance the radius r. So the equation of a circle whose center is the point a comma b, or the radius of r, is x minus a squared plus y minus b squared equals r squared. That's an equation whose graph becomes the circle, all the points a distance of r away from the center a comma b. So find the center and radius of the circle whose equation is x minus 1 squared plus y plus 2 squared equals 9, and then sketch the graph. So the center and the radius we just pick out from the equation. A and b were the center, but notice we were subtracting a from x and subtracting b from y. So what number are we subtracting from x here? We're subtracting a positive 1. It's x minus 1. What number are we subtracting from y? Well, we're actually subtracting a negative 2 if we had x plus or y plus 2. So the y coordinate of the center is negative 2. So really you're taking the opposite sign of the numbers as they appear to you in the equation. So the center is the point 1, negative 2. We could plot that on the graph right now. 1 for x, negative 2 for y. And the radius is the square root of the number on the other side of the equation, because that number is r squared. So r squared is 9, that means r is 3. So 3 is how far we go away from the center to get to every point that's on the circle. So if we move up 3, 1, 2, 3, that's a point on the circle. If we move to the right 3, 1, 2, 3, that's a point on the circle. If we move to the left 3, 1, 2, 3, that's a point on the circle. And if we move down 3, 1, 2, 3, that's a point on the circle. And there's infinitely many other points, but having those 4 at least allows us to get a good graph of the circle. And that's what we're asked for. So let's write the equation of this circle. We've got the center. The center is 5, 6. And the radius, r, is 4. So we remember that the formula is x minus a squared plus y minus b squared equals r squared. X minus 5 then squared plus y minus 6 squared equals 4 squared. And so we'll just leave our answer as x minus 5 squared plus y minus 6 squared equals 16. And that is the equation of the circle. Every point x comma y that satisfies that equation is a point on the circle. And our last concept for this video is the midpoint between 2 points. The midpoint of the segment that joins points x1, y1 and x2, y2 is the point whose x-coordinate is x1 plus x2 over 2, and whose y-coordinate is y1 plus y2 over 2. So basically you're averaging the x-coordinates to get the new x-coordinate. You're averaging the y-coordinates to get the new y-coordinate. You average them by adding them up and divide by how many you have. So adding them up and dividing by 2. So find the midpoint of the segment that joins negative 11, 3 and 8, negative 7. So it's an x-coordinate and a y-coordinate. The x-coordinate, we add up the 2 x-coordinates we have, negative 11 plus 8. We divide that by 2. The y-coordinate, we add up those, 3 plus negative 7, and divide by 2. So what is negative 11 plus 8? That's negative 3. And it's divided by 2, so negative 3 over 2. And what is 3 plus negative 7? That's negative 4. And it's divided by 2. We'll simplify anything that we can. Can't really simplify negative 3 over 2, so we're stuck with that. But we can simplify negative 4 over 2 and get negative 2. So our midpoint is negative 3 halves, negative 2. And here are your immediate practice problems. Take the 2 points, negative 6, 3, and 2, negative 4. Number 1, find the distance between the points. And number 2, find the midpoint of the segment connecting the 2 points. Show your work for both of the problems. And that's the end of sections 13.1 and 13.5.